When it comes to inequalities with systems of linear inequation, when it comes to systems of linear inequalities, we're going to treat them as we did at the end of chapter 2 when we were graphing just regular, graphing two-variable inequalities. Only this time we're going to be graphing both lines and doing the process for both situations. So first, I'm going to rewrite each equation as an equality. So, first off, I'm going to have x plus y is equal to 6. Putting this into, I'm quick graphing this on a standard form. Finding my x-intercept means that I substitute 0 for y, which means that x is 6. And so I'll have the point 6, 0, which is this point out here. And substituting 0 for x, I have y is equal to 6, or the point 0, 6 is also on this graph. So, and that's this point up here at 1, 2, 3, 4, 5, 6. With 2 points on this graph, I can quick draw my line of this equation. Which goes right like this. I want to make sure to draw the entire line. Now, to determine whether or not it stays solid, we go back to our inequality. Because it is also or equal to, we'll leave this as a solid line. Now, evaluating my second inequality, I'm going to first write it as an equation. So here is 2x minus y being equal to a positive 4. I subtract 2x from both sides. I find myself with the opposite of y is equal to a negative 2 times x plus 4. And multiplying everything by a negative 1 to get y by itself, I find myself with y being equal to a positive 2x plus a negative 4. All I did was simply change my signs. Now I have what's known as a slope-intercept form. If you wanted to calculate from here and do the same thing, that's totally up to you. I'm just showing you both ways. Graphing in green, I'm going to start at a 0, negative 4 on my y-axis. And I know that I have a slope of positive 2, so that means that if I go up 2, I'm going to go 1 unit to the right. And I'll go up 2 more. There's 1 more unit to the right, just for good measure. And now, speaking of measuring, we're going to draw this line in. Okay, I'm drawing in this line here. Okay, we're going to take and connect these 2 points. And now in my green, I have a line y is equal to 2x plus 4. Checking this line to see if it should still remain solid or dotted, we go back to our inequality. Because it's simply greater than and not greater than or equal to, this will be a segmented line. So here we are, with 2 lines drawn. We see if this was an equal sign, or if this was a system of equations and not a system of inequalities, we would have exactly one answer. However, x plus y needs, we're now doing some shading, as well as with this 2x minus y. And we actually have 1, 2, 3, 4 different regions. To evaluate which region will be true for us, we can take this one step at a time. So, with respect to our blue line, which again was our blue line is x plus y needs to be less than or equal to 6. I'm going to pick a point that's conveniently located on one of the regions, either 2 and 3 or 1 and 4 of that blue line. Here's the origin, and I love to test at the origin, so I'm going to test there. This has the point 0, 0. And I'm going to check, is my x value, which is 0, plus 0 less than or equal to 6? And yes, it is, which means that this region would be shaded in blue. We've now limited ourselves to simply two regions, region 2 and region 3, because we know that region 1 and region 4 don't satisfy our first inequality. Now, we test a point in either region 2 or region 3. Because I already have the point 0, 0, I'm going to test for region 2 to see if that will also be true for my bottom inequality. Testing that, I'm going to see if 2 times 0 minus 0 is greater than 4. Racing, I have 0 minus 0 is greater than 4, and since 0 is not greater than 4, I know that I will not be shading in green this area. Instead, my green shading will happen on the opposite side of that line. So in this case, we have shading in regions 2 and 3, but only green shading and blue shading in region 3, which means that region 3 here is the answer to this system of linear inequalities.